Everyone, and welcome to Fibonacci series through recursion. To generate the Fibonacci series using recursion in C, you typically need two main parts: a recursive function that calculates the nth Fibonacci number and a main function that calculates this recursive function for each number in the desired range of the series. So here's the C code. First of all, hash include studio.h, which is the imported file. The recursive function to calculate the nth Fibonacci number is int Fibonacci, and the parameter inside we are giving is int n. So the return is also int, and the passing parameter is also int. Now the base cases are 2, 0 and 1. So if n is less than equal to 1, which is 0 and 1, return n. So we don't have to do anything after that. And the recursive step will come inside else. Else return Fibonacci n-1 plus Fibonacci n-2. Why we are doing n-1 and n-2? Because this is the formula for Fibonacci. Fn is equal to fn-1 plus fn-2. That is, the current number will be equal to the previous one and previous two. Previous 2 plus previous 1. So previous 2 is Fibonacci n-1 and previous 1 is Fibonacci n-2. So we are just applying the formula here. Fn is equal to fn minus 1 plus fn minus 2. It is nothing much. Now the main code for loop comes inside int main. Just take in count, get the number of terms from the user, printf enter the number of terms for the Fibonacci series, scanf the digit and ampersand count. Check for the valid input. Again, we will have to check if count is less than 0, then please enter non-negative. Else printf Fibonacci series first %d terms and then \n count. Why we are giving \n? It is not backslash, it's forward slash. It is for the space. So forward slash n is for the space. It's for the new line. So what we are doing is Fibonacci series, printf Fibonacci series, first decimal, not the decimal, first digit terms count. So first digit terms colon, and then we have a space, that is a forward slash n, and then count. And count we are taking from the user because we are taking from printf. Please enter a non-negative number of terms forward slash n, because every time we have to give a new line. So for the new line we are giving forward slash n. Now simple loop we have to write for the Fibonacci number. For int I is equal to 0, I less than count, I plus plus, printf %d. So this is the format we all know in C. %d is for the decimal, it's not for the decimal, it's for the digit, and then comma Fibonacci I. So Fibonacci I, this is the recursive call we are doing here. We are calling Fibonacci function method which we have made earlier here inside printf, inside the for loop, and then close the curly brace, and the next line would be printf \n. So simply we are printing the next line so that our sequence generated will be always, the number will be on next line, like 0, 1, then we have 3 in the next line, then we have 5 on the next line, then we have 8 on the next line, and at last return 0. So always in main we have to, inside the main function, we always have to return the 0. So what we are doing is we are calling this recursive call of Fibonacci I inside the for loop, and this Fibonacci I function, which is the Fibonacci n, we have declared here. We have declared this function by the return is also int and the parameter taken is also int, and the recursive step is Fibonacci n-1 plus Fibonacci n-2, which is a simple use of the formula. So the use of the formula is the recursive step, and this is also recursive call, like we are calling this method here Fibonacci I. Okay, so now the explanation is Fibonacci int function. This is the recursive function that computes the nth Fibonacci number. Base cases is n is 0, return 0, n is 1, return 1. That's why we already took above 1, that is greater than 1. These are the starting points of the Fibonacci series. F of 0 is 0 and f of 1 is 1. So without these base cases, the recursion would never terminate. If we don't have these base cases, the recursion would never terminate. Recursive step is, if n is greater than 1, it returns the sum of n-1th Fibonacci number and n-2th Fibonacci number, that is previous minus 1, that is previous 1 and previous 2, that is previous 2 and previous 1. The sum of both is current. This is achieved by calling Fibonacci n-1 and Fibonacci n-2 recursively. This directly implements the Fibonacci sequence definition fn is equal to fn-1 plus fn-2 and main function. It prompts the user to enter the number of terms they want in the Fibonacci series. So it includes a basic input validation to ensure the user enters a non-negative number. It also includes a validation, and it then uses a for loop to iterate from 0 to count -1, and in each iteration it calls the Fibonacci function with the current loop variable I to get ith Fibonacci number and print it. So how recursion works in Fibonacci 4 and Fibonacci 4. So we get Fibonacci 4. If you have to calculate, then it will be Fibonacci 4 will be Fibonacci 3 plus Fibonacci 2, and then the next one will be Fibonacci 3 will be Fibonacci 2 plus Fibonacci 1, and Fibonacci 2 will be Fibonacci 1 plus Fibonacci 0, and Fibonacci 1 will be Fibonacci 1 plus Fibonacci 0, and then again Fibonacci 1 will be 1 and Fibonacci 0 will be 0. So 1 plus 0, so 1 plus 0 is 1, so 1 plus 0 is 1 plus 1 plus 1, which is 2 plus 1, which is equal to 3. So in this way we are going to calculate, this is the dry run. This is known as the dry run of Fibonacci 4. If we give n is equal to 4, then this is a dry run. So why we said this is not going to terminate, the recursion will never terminate if we are not going to give f the value of f0 and f of 1. So these are the basic two values. F of 0 is always 0 and f of 1 is always 1. That is why the recursion will be not be infinite, it will terminate. The function calls itself repeatedly, breaking down the problem into smaller similar subproblems until it reaches the base cases, at which point it starts running values back up this call stack. So this is like upward stack. Now important note is on efficiency. While this recursive implementation is straightforward and directly reflects the mathematical definitions of Fibonacci sequence, it is highly inefficient for larger values of n. This is because it recalculates the same Fibonacci numbers many times. For example, Fibonacci 2 is calculated multiple times when finding Fibonacci 4. So this leads to the exponential time complexity, which is O2 raised to the power n. So for practical implementations, especially when dealing with larger numbers, an iterative approach or dynamic programming memoization is much more efficient, which is simple for loop. If we use, then it will be much more efficient. So thank you so much for watching.